All right, so now we're back in BlueJ to see how this thing really works. So these two files are going to be exactly the same as your textbook. First I have Postfix tester, which is going to be our driver, right, which kind of provides the test scenario for this thing. And then Postfix Evaluator, which is going to be our class that actually implements the algorithm for computing the value of these expressions. Let's start by actually running this thing. So let's go to our Postfix tester, run it, and see what we get. The first thing we see is a prompt asking us for an expression, right? So the whole way this program is structured is it's going to ask us to type in an expression on the keyboard, and then it'll evaluate it. And if we want to do more expressions, it'll let us do that too. So over here, I've actually already put one kind of on my copy-paste board. So I'm going to paste in this postfix expression that I already had. It's actually just the example one here from the text here. So let's assume we had typed that in. Let me press enter. So this algorithm, right, is going to read through that expression, right? It's going to read through that string that we've just typed in, and then evaluate it. And it gives us back the message saying, oh, that expression equals 36. And if we want to, we can either do another expression or we can stop. So maybe we do another expression just to see what happens. Let's go yes, and let's just try something simple like 10 plus 42. And let's see if that works. Press enter. That expression equals 52. All right, so this thing looks like it works. It's going to just loop and keep on asking us to enter these expressions. Let's go ahead and click no. Now that we've seen how this program actually works from a user's perspective, let's take a look at how it's actually implemented. The first thing I want to do is start with a postfix tester, because that's our driver for the whole thing, right? That's going to be what implements that loop that reads in these expressions from the user before it applies that algorithm to figure out what they evaluate to. So over here, I just have a main, right? There's not a lot in here. Everything's just kind of over in my main method. So just starting from top to bottom, we see that the first thing we have is a couple of variable declarations. First, we see that we're declaring two strings. We declare an expression, and we declare again. So expression is going to be a variable I use to hold whatever the user types in, right? So the user is going to type in some postfix expression, and I just need someplace to store that. Again, is going to be the variable we use to read in the user's input when we ask whether they want to continue or not. After those two, we have a third variable called result. And this variable now is an integer. This is what we'll use to actually store that numerical result from parsing that expression, right? From using the postfix evaluator on it. We'll store that result into the result variable. Next thing we have down here is pretty familiar. This is just creating a new scanner object so that we can read input from the user and then process it. The heart of this method is going to be the while loop here, or I should say the do while loop. We have a do while here because we always want to prompt the user at least once, right? We want to make sure the user is entering at least one expression before we quit out. So let's take a look at the code inside of that. The first thing this loop does is creates a new postfix evaluator object. So over here it says postfix evaluator. So this is a type, right? It says create a new variable whose type is postfix evaluator, and then call that variable evaluator. And then over here on the right-hand side, we have our new postfix evaluator, which is essentially our call to make a new object from that class that is available. So at this point, we've just initialized an object that lets us parse expressions, but we still need to get input from the user. So what we'll do is we'll print out some information. We'll let the user know, oh, they need to enter a postfix expression. This is how it looks, and this is an example of how you can type one in. More text, again, just explanation so the user knows what's going on. And then once we have that out of the way, we're going to prompt the user for a new expression. We're going to say in.next line, right? So just go to the scanner object we created earlier and get the next line of text that the user's entered, right? The user's going to type some stuff in and press enter, and that stuff ends up over in this variable here called the expression. Once we've read in our expression, we'll actually be able to evaluate it. So what we'll do is we'll go to our evaluator object, right, the one we created earlier from the postfix evaluator class, and go .evaluate. So we're going to call the method evaluate from the evaluator object that we created. And then as a parameter of that, we're going to pass that expression that we've read in. That method will then work, right? It's going to analyze, it's going to parse through that expression, it's going to figure out what it results in. And then it'll return it, right? So this part here is returning that result of evaluating the expression. That result then is going to be stored into our variable we created here called result, right? So that's where I'm going to store what it evaluated to. And then these next couple of lines are just going to go through and they're going to print out that result for the user to see, right? So they have some little explanatory text, and then they print the contents of the variable called result, which is where we stored the result of running the postfix evaluator on that expression. Once we've done all of that, we'll kind of have some generic code here. So we'll say, oh, do you want to evaluate an expression or not? Y or N. We'll read another line. And then over here in the end of our while loop, we have some familiar code which is going to check what the user entered, right? Did they enter yes? Did they enter no? And based on that, it'll choose to loop again. So this is the body of our whole program. The basic idea is make a postfix evaluator object, right, that can parse these things we're going to be reading, and then read an expression from the user and pass that expression to the evaluator object, then get the result from that, and then display it back to the user, and then prompt them to say, oh, do we want to do this again or not? Overall, we haven't really done work on the postfix expression itself. All of the kind of the processing that happens is all going to be in this evaluate method that's actually inside of the postfix evaluator class, right? So this class, right, postfix evaluator, is encapsulating all the information that it has to do specifically with postfix expressions. In that case, let's go ahead and jump down to postfix evaluator and see how that thing works. So over here we have a class. This is a lot longer than what we've seen before. This is over 100 lines of code. So let's just walk through this. Again, we'll do top to bottom and see what everything means. So the first two lines we have in this program, or in this class I should say, are import for stack, import for scanner. So these are going to be the two packages we bring in because they give us useful stuff. For a scanner, we've seen it in the past when reading in input from the user. We're actually going to use it again here in order to split up the text that the user's typed in. We want to get at the numbers or the operators between the spaces. We don't want to have to worry about how these things have been typed in, right? We just want to have the actual information available to us. And scanner will give us a way to do that. The other thing we have here is stack. The reason we need this is to actually create that stack that our algorithm involves. Remember that we're going to be pushing on numbers onto a stack whenever we see them in an expression, or popping them off whenever we see an operator that needs to actually process them. So scrolling down, we have our main class. And we're actually going to come back in a few minutes and talk about this stuff over here. This is something called JavaDoc. So let's scroll down a little bit. Here's the beginning of my class. So the first four things I have in here are going to be defining what our symbols are, right? What is the add symbol? Well, the add symbol is the plus symbol. Subtract, minus symbol, multiply, star symbol, divide symbol, slash, right? Our goal here is just to give more legible names to these symbols. This may not be very important, but anything we can do to kind of make our code more readable is going to be a good thing to do. After that, we have this line here. So this is kind of the first new thing we see. So what this is this is declaring a new variable of type stack integer. Remember over here that this integer, because I have arrows around it, this is indicating that this is a generic. So this whole line here is saying, make me a variable that stores a stack that contains integers. And that's going to be the place that we store all of our numbers when we read in an expression and try to parse it. So let's scroll down a little bit. First thing we have is going to be our constructor. So our constructor, postfix evaluator. In here, there's only one thing we really need to do, which is set up the stack. Before, right, we had just created the variable, but now in here, what we'll do is we'll go to that stack variable and we'll set it equal to a new stack object. So at this point in time, right, once this line is executed, we're going to have a stack available to us that we can put numbers into, right, or take numbers out of. The next method in here is called evaluate, and this is where the bulk of the work happens. So this is the method we called over in our main method, right, to evaluate a string and give us back a number. And you can see that kind of in the same signature of this method. This method itself is called evaluate, and then inside of it, we're going to take one parameter, and it's going to call expr, right, for short for expression. It's going to be the thing that we're reading in, right, from the user. And then notice that its return type over here is int, right? So we take in a string, give back an int. Jumping down, we see that we have several variables being declared now. So op1 and op2 are going to be temporary variables I use whenever I need to get something off of the stack. Remember that we said that whenever we see an operator, what we're going to do is we're going to pop two values from the stack and then apply that operation to them. So op1 and op2 are going to be where I actually store those two values. The third thing I have here is result. And result here is just initialized to 0, and that's where the final number, right, the final thing I compute is going to be stored. And that'll end up being the thing we return at the very end as well. My next line here, I have a string token. So token is kind of a general term we use to refer to a piece of text, right? So imagine we have our postfix expression, right? Our postfix expression looks something like this, right? A token is saying that, oh, we've taken a string, we've broken it up, right? So 5 might be a token, 4 might be a token, plus might be a token, right? We want to break some bit of text into little chunks, right? Little tokens, if you would. That'll make it easier for us to process them. And of course, tokens can have more than one digit in them, right? So if you had a number like 1,000, then the whole token would be 1,000, right? It wouldn't just be one and then some zeros. It'll be kind of the whole thing between a couple of spaces. So that's going to be our variable, right? That's just going to look at each thing in turn within the expression. Our next line here is pretty important. What we're going to do here is we're creating a new scanner, this time called parser. And then this scanner, when we create it, we're going to point it at expression, right? That bit of text the user entered in. So instead of actually taking in information from the keyboard, this scanner is going to read along the information that's stored inside of that expression that the user typed in earlier and which was passed in as a parameter. By default, the scanner is actually going to look at that expression and it's going to tokenize it, right? It's going to break it into pieces based on the spaces, right? So it's actually going to give us that 5, 4, plus 3, and so on and so forth. It's going to go through and break everything up for us, which is what we want so that we can easily process each of the things that's inside. At this point, we have all our variables set up. And what we need to do is we need to process through the expression, right? And that expression is now going to be available to us via the scanner that was stored into parser based on that expression. Now, inside that parser, there's something called hasNext. What this is going to do is it's going to check to see whether there's any more tokens created from the expression that we need to process, right? Are we done yet or not? So we'll keep on looping while there's still some token inside of it that needs to be processed. So let's say this ends up being false and we have some stuff to work on, right? That string isn't empty yet. The first thing we'll do here is this, token equal parser.next. The idea is we go to parser and we take out the next element that's inside of it, right? So initially, right, we might get something like a 5, right, if we were to parse this thing over here. So we'd get kind of the string that stores the number 5, right? The first token that's inside of it. And that would be stored into our token variable over here. So let's say this is storing 5. And remember, it's storing it as just a string. It's not a number yet. Then we have this if statement here. This if statement here is going to look at my token and act differently based on whether it's a number or it's an operator. So the first conditional here, you can see, it's going to go if is operator token, right? So it's going to check to see whether token's an operator. This is operator thing is actually a separate method, and we'll go talk about it later. For now, just think of it as something that's going to return true if that token, right, if the thing we took out of the expression is equal to plus, minus, times, or divide, right? If it is, then this ends up being true. Otherwise, it ends up being false. So let's say that token was a 5. In that case, this is going to be false. So this is whole code here, right? This little bit here will be skipped, and instead it'll go over to the else branch. That else branch is relatively simple. What it does is it takes that input, right, that token that we've typed, and first of all, it converts it to an integer. So it does this integer.parseInt, right? So that's a way to take a string and make an integer from it. So once we have that, we're going to take that integer and we're going to do what they call wrapping or boxing, and we're going to take this raw int and we're going to make it into an integer object, right? An object that contains that number. Once we have that, we can take that object, right, the integer object for that number 5, and push that into our stack. So that at some later point, once we get to an operator, then that method will be able to go through and take that 5 back out and use it to calculate what the value of that operator should be. Let's say we were further along in this expression though. Let's say token was that plus, right? So let's say we had already put that 5 and that 4 on the stack. What would happen? Well, over here, if this was going to be a string containing just a plus symbol, our isOperator method would actually be returning true. In that case, this true branch here will run. So this branch has 4 lines in it. The first 2 are kind of similar. What they're going to do is they're going to go to the stack and they're going to pop a value from that stack off, right? So they're going to get a piece of information. And then they're going to convert it to be an integer, int value. So just converting it to an integer or converting it to an int. Integer is the name of the class, int is the name of the primitive type. Here we want to make it into an int itself. Take out the first thing, take out the second thing. So now we have our 2 operons, and now we need to apply our operator. So in this case, there's actually another method we've implemented called evaluate single operator, and this thing here is going to take in the operator that we saw, and then the 2 operons that we just popped off of our stack. And then this method as a whole is going to apply whatever this operation is to those 2 numbers that were removed. The result of that is then going to be stored into our result variable over here, and this result variable it's going to be wrapped into an integer again, and then it'll be pushed onto the stack, right? So we've taken 2 things off, evaluated them, and then put the result back on the stack. And so if we just think back, this whole process here, right, of either putting numbers on there or when you see an operator taking numbers off and computing them and then putting the result back on. This process is just going to repeat over and over again, right? As long as there's either a number or an operator still in that expression, right, that we still need to parse. While that parser still has the next element to parse, this thing will loop. And then at the end of the day, the last operator that was run, the result of that is going to be stored in the result variable, so we can just return the result variable down here. As kind of a side note, if you're kind of going through this code and trying to understand it, there is actually a slight bug in here in the code that the book has. It's actually possible to give it an expression that won't evaluate to the proper value. So maybe if you're interested, you can spend a few minutes by yourself and try to figure out what that little bug is in this code and how to fix it. It'll end up being about a one-line change. Otherwise, you don't really have to worry about it because it won't really affect anything in our example. It's just kind of a little typo almost. So let's go down here, take a look at the last couple of methods we need. So the first one's going to be isOperator. So this is what we use to decide what we should do to each token in that input expression. So over here, we're going to take in a string as a parameter, right? So we're going to take in the token that was seen by the parser, right? That was produced by the scanner. Over here, we're going to take in the token that was produced by the scanner when it was reading through that expression that the user had put in. All it's going to do is it's going to check that token against a different symbol. So it's going to see, oh, is the token equal to plus? Is it equal to minus? Is it equal to times? Is it equal to divide? If any of those are true, right? So these are or symbols, right? So we're checking to see whether this is true, or this is true, or this is true, right? If any of those end up being true, then this whole thing will return true, right? And it'll say, yes, this is an operator, and so you need to pop stuff from the stack and then evaluate it. If it doesn't match any of these, right, if it ends up being a number or something else, then it will return false, right? Because none of these will end up being true, so that entire expression, right, this entire thing here will end up being false. The last method we have here is evaluate single operator. So this is what we use to actually compute the different values that our expression involves. So over here, right, we have three parameters. We take in an operation, op1, op2. Really quick over here, you'll notice that operation isn't a string. In this case, it's actually just a char. This is kind of how the algorithm was set up. It doesn't really matter. If you look at the original evaluate method, you'll notice that they have a little step there where they convert the expression from being a string to a char, so they can pass into this method. But it really doesn't change anything. For now, we just care about the fact that operation is going to contain the single character that corresponds to the operation that needs to happen, right? The operator that we're going to be acting on. Op1 and 2, right, are the integers. They're the things that we popped off the stack and that we need to actually apply the operator to. So in the body of this method, we have a little bit of code. It's not that bad, although it does use a switch statement. The first thing we do in here is initialize a variable. So here we create something called result. Result will just set equal to 0. This is going to be where we store the result of computing the operator on the two operands that were passed in. We'll just set it to 0 so that Java doesn't complain about not knowing what's supposed to be stored inside of it. The main part here in this method is going to be the switch statement. So the switch statement is going to switch, right? It's going to make its decision based on what is the value of operation, right? Based on the character or the operator it's being passed in. And there's 4 different cases that can happen: add, subtract, multiply, divide, right? And those cases, right, based on what is passed in, right, what symbol is passed in, the appropriate case is going to be selected, right? So let's say we pass in the plus symbol. In that case, the case add is going to trigger. And the reason it triggers is that earlier in our program, we defined the word add to be the plus symbol, right? So over here, we define add to be plus, subtract to be negative, and so on and so forth, right? So we've already defined these key words, right? We've defined them as constants, so we can use them down here in our switch statement. And so if we pass in something like a plus, that plus is going to match with this case add, right? Because add was already a plus symbol declared up top. And then this code in here will run. So in this case, we know we've seen an addition, right? We need to add these two things together. So we'll set result equal to op1 plus op2. So result will be updated, and then the switch statement will end, and the result will be returned, right? The addition that took place. If it's something like subtract, then it'll end up in a different case, right? And in this other case, right, result is going to be set equal to op1 minus op2, right? So that different operation is over here, right? So instead we're doing the subtraction. But then that result is still going to be stored back into the result variable, which is returned by this method in the end. So there you have it. That was an outline of how the different parts of the Postfix evaluator work. I know this isn't maybe the most interesting example, but it's still a very concise example of using a stack to store information for some sort of processing that needs to take place. I would suggest you spend some time to play with this. Maybe try writing some other postfix expressions, seeing them evaluate. You can also think about maybe adding some print statements in here to see the different parts of the program work, right? So you could add print statements that print out each expression as it's read, or each token as it's processed, right? Or which branch is used in this evaluate single operator. You could do whatever you want.